Well, welcome back to Barley and Hops. I'm George, and this is the channel that dares to unlock the mysteries of home distilling. Our intent is to make you as successful, but at the same time, to make sure that you are safe in your application of any of these processes if you should desire to endeavor into this hobby. Okay?
Come all you moonshiners if you want to hear.
First, let me say that I wish you all the very best during this period of time that the world is going through a pandemic of which we haven't seen before. Of course, we shall all get over this, and I am confident that we are all in this together, and this too we shall overcome. Now, I often receive questions, emails, calls, comments, and a lot of it has to revolve around this allure of, the sugar wash or a grain bill or whatever the case may be, in that George, it's stop fermenting. And we've done a video before on stuck fermentations, and they happen from time to time, and they happen for many different reasons. But the one we're going to discuss today is the one that most people, I'd say, not all, but are victim to, and that is expectation levels, okay? And we're going to discuss that in great detail. And I've got a test here. We're going to use a scientific approach, but we're going to explain it at the very same time. So I'll go to the whiteboard. We're going to show you what we're doing and how we got to where we're at and what we are going to do to scientifically prove our hypothesis, which is, yes, too much sugar is not a good thing. Okay, let's get directly to the point, okay? Way too often I hear and receive feedback and questions about a sugar mash or a sugar wash. And remember, the term wash and mash are kind of used interchangeably. There are some slight differences, but we would normally classify sugar and water as to be a wash. But it doesn't matter what you call it. All right. We always advocate when I talk with people is that about 2 pounds per gallon, or just short of a kilogram per 3.7854 liters, is probably a good limit. Okay. So what that would mean, now let me go straight U.S. only on this one because it's easier to do off the top of my head, which means that in 5 gallons, if I say two pounds per gallon, that would be the water. You probably have 10 pounds of sugar. Now, can you use 12? Yes, you can use 12 pounds. But remember, this is only a good starting data point, okay? So I wouldn't go much above 12. Only because, see, now we're going to explain why, and there is a big difference, and there is a reason for that. And this may be what some people are suffering from. And it's really, you're suffering from your level of expectation and misunderstanding of the science and the biochemistry behind what actually happens in a sugar wash. And it's relatively simple. Here's what we do know, and I measured this today, as a matter of fact, that 1 pound of sugar in 1 gallon of water is, actually, I came up with 1.039 was my gravity points for 1 pound of sugar in 1 gallon of water. So that's my data point. I know that. So I can use that to do all the math formulas to determine how many pounds I need for what gravity points I'm looking. You follow me? I mean, it's that, believe it or not, it's that straightforward. My goal whenever I make a wash or a mash or whatever the case may be, my initial gravity before I pitch my yeast, I normally look for 1.090. And that results in about 13% ABV. But it's slightly below 13%, but I use 13 as it's just easy to explain that way. So, and remember that commercial distillers are somewhere between 8 and 11. They're happy. You retain a whole lot more of the flavor profile And you can manipulate that a whole lot easier. Because remember, when you start getting way above that, you're no longer making spirits, you're making fuel. Now that's one thing to consider. The second thing to consider is, see, I get so many people that say, well, if 10 pounds in 5 gallons is a good starting point, well then why not 20 pounds in 5 gallons? I actually had someone write in and say, George, why are you wasting your time with all the water? Why don't you just put all 12 pounds in a gallon? Okay. Actually wrote back and said, give it a try, let me know how it works out. Here's where we have our challenge, and this is what we need to understand. That most living creatures, microorganisms, fungus, I mean, those, in order to be viable and actually operate, what do they require? They require the proper environment. They require some food, something in which to process, right? And in this case would be sugar. But you need a medium. There's something else that's missing that you've got to have, and that is water. So when you have all those together, then you've got the perfect environment. See, this is the environment you're creating in water, because water is like the elixir of life. Sugars are the foods of life. And so if you get the proper mixture of that, you have a really robust reaction and a result from that. Most organisms require, let's take yeast as an example. But yeast falls into this category. 15% of the water, because they will absorb water when they get going and they start to propagate and they're starting to bud off and starting to eat those sugars and creating those ethyl alcohols. Okay, now, so they need at least 15% water just to be viable. So when you take a 5-gallon batch of water, so a good majority of that volume of water that you have in here is taken up by all those sugar molecules, okay? And those sugar molecules, now that they liquefy, they start to drop it a little bit closer, okay? They've soaked up this water, they've become soluble themselves, and now your yeast are in competition for the water, not the sugar, the water. So if you increase that sugar content, what are you doing? You are restricting the water available for your yeast. Does that kind of make sense? And we're going to prove it to you through this simple experiment. Now let me get set up and I'll show you this. So this is the way the experiment will work, okay? We're going to take 1 pound of sugar in 1 gallon of water, and then we're going to test 2 pounds of sugar in 1 gallon of water, which represents sort of like the average. Then we're going to go 3 pounds of sugar in 1 gallon of water for those who get a little bit rambunctious, and then for those who think way, way more is way, way better, we did 4 pounds of sugar in 1 gallon of water. And of course, I don't have all of that sitting out here. You saw the 4 jars in the very beginning. What we did is we scaled it down. Here's how this works out. See, water, by standard, here in the U.S. in particular, we deal with U.S. gallons and ounces. But I've put up the conversions up here for you. So I'd say here's my 1 gallon of water, 1 pound of sugar, 0.53 ounces of yeast, excuse me, which comes to about 15 grams. And I get 1.039 gravity points. So that's points per pound per gallon. All right? And so that's where that term comes from. So I know that if I put 1 pound of sugar in 1 gallon of water and I float a hydrometer, it should read 1.039. Now, what I did is I reduced it down to, I've got quart jars, and I reduced it down to a pint. So what I did was I measured the proper amount of water in 4 of those jars. And that would be 1 pint or 473.1 milliliters. I got them all in there. What I started off with a large volume of water in a half a gallon, and I made sure I got the pH correct and I got the equal temperature. So we started off with the same temperature at the same pH of 5.2. With me? All right. And then what I did was I added 2 ounces, because if I scale down the 1 pound of sugar, it equals actually 2 ounces in 1 pint. And it's 56.6 grams. And then I will introduce 0.7 ounces or 1.875 grams of yeast. All right, because normally I put 0.53, a half an ounce of yeast, which is quite a bit, a big heaping tablespoon. So I scaled that down as well. So everything should be equal. And in this case, this would equal 1. That would be the equivalent of 1 pound in 1 gallon, but we're going to do it on a smaller scale. Then what I did was I went to the next jar, see, and I added 4 ounces, 113.2 grams. I went to the next jar, added 6 ounces, 169.8 grams, and the last jar put 8 ounces, 226.4 grams. What you see that I left the same, though, was I left the yeast the same. And I left the yeast the same because we have to have the same environment across the whole board, the whole spectrum, in order to demonstrate this scientifically. And what this will represent is, this would be myself doubling, putting 2 pounds of sugar in a gallon. This would represent putting 3 pounds in a gallon. And this would represent putting 4 pounds in a gallon. Okay, I'm going to give you a close-up view here of the 4 jars. Now, we've already explained what we did. We scaled this down to 1 pint, which is 473.1 milliliters. And we introduced the appropriate amount of sugar to represent 1 pound in 1 gallon. Or, well, we've already gone over. 2 in 1 gallon, 3 in 1 gallon, 4 in 1 gallon. So you'll notice the differences in the volumes from 1 to 4. And you'll see how they start to increase as, that's decrease that way. You'll notice that they start to increase as you go across. And what accounts for that is, of course, you're introducing more volume when you increase the amount of sugar. So that sugar displaces a certain amount of that liquid that's there. Well, the more sugar, of course, a little bit more of the displacement. And I mean, there's a whole lot more going on there than we need to really worry about right now. But it should be understood that these are still all 4 equal, with the exception of the differences in the amount of sugar by weight that are in these. You follow me so far? Yeah, see, that gives us a baseline, a data point in which to conduct our experiment. So I hope everybody got that so far, all right? Now, in order for us to find out what happens is I have that 1.875 or 0.07 ounces of yeast to introduce into each one of these. And these are all at the same temperature, about 85 degrees. Whoa, I don't want to get those lids mixed up. Yeah, there we go. So I'll introduce the exact same amount of yeast into each one. And we're going to treat these all exactly the same, which means that we will shake them equally in order to get that yeast hydrated. Now, I am not going to use yeast nutrient. Why would I not use yeast nutrient at this point? Well, yeast nutrient will skew the results just slightly, because remember, the yeast nutrient, just like the sugar, is going to take up a certain amount of that environment. And what we want to know is, what are the effects of sugar, water, and yeast? And so what I intend to prove to you today is that, let me loosen those lids so that when it does start to ferment, we don't blow a lid. What I intend to prove to you today, we're going to give this about 15 to 20 minutes to see what the results are, is that the reason why a sugar wash will stall out after it goes through its aerobic phase, where there's the introduction of oxygen and it gets started, is that depletion of water that's available When you increase the amount of sugar dramatically, you push out the available water that's available. No, actually, you reverse. You actually restrict the amount of water that's available for that yeast colony in order for it to develop and develop a strong, viable colony. Therefore, your yeast just stop. There's not much you can do to it. Normally, the result that you'll have is you'll have a very, very high gravity. And you'll notice in this point that for 4 pounds per gallon, you'll start off at 1.156. And that's dramatically high. And when that happens, I'll have people that'll call me and say, it's what it started out at, and it stopped at 1.00, 1.100 or 1.095. The only thing you can do at that point is split it. Yes, you don't have enough water for your yeast to propagate, so split your batch into 2 and add more water, dilute it, allow your yeast more water in which to function in, and then it'll start to ferment again. When it does ferment, of course, you're not going to wind up with you'll wind up with the same alcohol by volume overall, but you're just going to wind up with a larger volume of water. And once you put it all back together, you'll still have the same amount of alcohol. Again, it's 6 of one, half dozen of the other, however you want to look at it. But if you don't dilute it, all you're doing, there's nothing else you can do to it. Okay? So my rules of thumb are, if you haven't exceeded the gravity, and we'll find out where that point is. If you haven't exceeded the gravity, give it a stir, warm it up. Chances are it's too cold. And normally it will start fermenting again and it'll go through its phase. If you had an extremely high gravity and it stopped, the rule of thumb is dilute it. Split it in 2, add water to both buckets, and then it will take off again and it'll do you justice. So let's give this some time to see what happens. Now we're watching this closely. Now this has been like this is about 10 minutes. This is not a final, but this is indicative to what we started to talk about. And you'll notice here in the first jar with the equivalent of 1 pound per gallon, it's cloudy and there's quite a bit of movement, and I can see some foam starting to develop on top. In the second jar, quite a bit the same thing with the 2 pounds per gallon equivalent. It's a bit cloudy. I've got yeast moving around in there, and things are starting to take place. Now my third jar, where I have an equivalent of 3 pounds per gallon, there's a noticeable difference between these two, where there's not as much movement. I've got a lot of yeast just suspended, and in this last jar, it clearly there's a difference where I'm just suspended and they're just sitting there. So we're going to give it some more time and see if we can come up with some more results to share with you. This is simply amazing. Now we're 10 minutes further into our experiment. Now you'll notice here on the very first jar, I've got a lot of activity. You may be able to see that on the video. I can see all these yeast moving around here, and I got a pretty good cake head on the top. Same thing with my second jar, not quite as active. Now my third jar, there's a definite difference between the second and third jar that is slowed down. And my last jar, it appears as though I've just got yeast suspended in a liquid without much activity at all. So, well, we've waited an additional 20 minutes just to give you some results. Now it is clear, you can see this, and this should be your convincing point, that in our first jar we've got a healthy yeast cake growing on top, and I can see a lot of activity, and it's rather cloudy, and that's a good thing. In our second jar, that represents 2 pounds in a gallon, we've got a similar event going on. Not quite as rapid, but it's still the same thing. Now when we go to our jar 3 with 3 pounds per gallon, I don't have a full cover over the water itself. There's still some spaces where there is no cake development, but there is some. And then in yeast are in jar number 4. It looks primarily the way it did when it started. I've got a lot of suspended yeast, I can see that, and absolutely no activity. So this should convince you that more sugar is not necessarily a good thing. Now, one result or one response may be, well, George, why don't, what about putting more yeast? Well, will more yeast resolve the issue of too much sugar? Well, stop and think about that. Your yeast require water in which to be viable and propagate. If you add more yeast, you are going to absorb more water. If you start off with less water than necessary to keep a colony viable, and you add more of that colony, what are you doing? Yes, you're going off the deep end. You're making matters worse as opposed to trying to make matters better. So what does this tell me? Well, this tells me that what we've advocated for years, that 2 pounds of sugar per gallon is a pretty good starting point. What is the sweet spot? It's totally going to be up to you, but it is somewhere in between the 2 and the 3 pounds per gallon. I don't know if I'd go as far as 3, but I'm quite sure since I've got an effect, somewhere here in the middle is going to be the limit. So 2 pounds is a good place to start, and then adjust your sugar based on your gravity points. So what should we be shooting for? We should be looking at gravity points as opposed to trying to achieve 22% alcohol by volume. Where's the limit? You've got all this knowledge now. You figure out what that limit is. And as always, the proof is in the process. Happy distilling.